Pleasant day, STEM learners. This is Sir Peter, your basic calculus teacher. So we are now proceeding to our next topic. We actually inserted one topic, which is lesson 3.3, the integrals involving logarithmic functions, because it is related to our next topic, which is lesson 3.4, a separable differential equation. So this is still part of our chapter on integration, but actually in college, differential equation is a separate subject. And one of the most common types of differential equations is the separable DE. So are you ready? So let us first define what is a differential equation. So a differential equation is a type of equation that involves x and y and the derivatives of y. So take note that we know that y is actually our y prime, right? That's the derivative of y. And we can rewrite it as dy over dx. So whenever there is the presence of x and y and the dy over dx, that's considered already a dE. So take a look at this example. We have dy over dx is equal to 2x plus 5. Then the second example, dy over dx is negative x over y. So whenever there's the presence of that derivative and the variables x and y, then those are what we refer to as the DE. Now, what is a separable DE? So a separable DE is an equation which can be written on this form. F of y dy is equal to g of x dx. So this simply means that all the function of y and the derivative of y should be located on the left side. And all the functions of g of x and the derivative of x should be on the right side of the equation. So if you can separate that one, then that is a separable differential equation. So here are the steps in writing a separable DE. So step number 1, you separate the variables by moving the y terms, including the dy to the left side. So again, all of your y and dy should be on the left side. And the x terms, including the dx, to the right side. We can use cross multiplication, factoring techniques, and other properties of equality such as APE, or you may directly transpose a certain term to the other side, applying addition property of equality, or you can divide both sides. Sometimes it will also entail multiplying both sides, so that's an MPE. For number 2, you have to integrate both sides of the equation. So you integrate the left side with respect to y and integrate the right side with respect to x. So there will be two integral sign that will appear on both sides of the equation. So you're integrating here in terms of y, then here you are integrating in terms of x. Third step, we will now find the missing value of c, or the constant of integration. So there is indeed a way of determining the c value by substituting a value or values which are what we call the boundaries, or what we call the initial conditions. And of course, this should always be the final answer. We should always solve for y, and there should be no other coefficients or exponent with y. So you have to make your y as simple as y. Like say for example, if it's a 2y, then you have to do something. You have to divide both sides by 2 so that y will remain. So if you have a y cube, then what you do here is to get the cube root of this value so that becomes y. So you have to do an algebraic method so that the final answer will be y. Okay? So after integrating both sides, remember that on the second step, what you obtain is always a general solution. That general solution always contains the constant of integration. For the third step, we will use the boundaries or the initial conditions so that you could find the value of the missing c. And after replacing the value of c, then you will arrive into another solution, which is what we call the particular solution. So this particular solution already has a certain value. So let's have examples. Let's find the general solution of the following DEs. Let's have number 1. dy over dx is equal to 4x minus 3. So for this type of example, the only thing that you need to do is to use cross multiplication. So we assume that this has 1, and then using cross multiplication, this becomes dy. Then this becomes quantity for x minus 3 dx because we cross multiply there. I hope you understand the method of cross multiplication so that it becomes this expression. Next, since all of the y values are on the left side and all of the x values are on the right side, we can now declare that this is a variable separable. So this is already a VS. Okay, so when it's a variable separable, then you can put now both the integral signs. So we integrate with respect to y and we integrate with respect to x. So what is the integral of dy? Of course, it's a y value. This is what we expect. And then we use the constant multiple theorem to answer. So we have y is equal to 4 integral of x dx minus 3 integral of dx. And then you'll arrive at, using the basic integration formula, we will have y is equal to 4x squared over 2 minus 3x plus c. So we apply the power rule, right? X plus 1 plus 1. And then in here, the integral of a dx is an x. That's why we have a negative 3x. And then plus c. Of course, we still need to simplify 4 and 2. So you'll arrive at the final answer, which is y is equal to 2x squared minus 3x plus c. Any question? Let's move now to the second item. Let's have dy over dx is equal to 7x squared minus x plus 5. Again, we apply cross multiplication. Simply put dx on that side. So this is now a variable separable. So it means we can now integrate the left side and integrate the right side of the equation. Next, we answer the integral of dy. Of course, obviously it's y. And then we use the constant multiple theorem by distributing dx. Any question? Then we apply the power rule, one of the basic integration rules. So that's 2 plus 1, 2 plus 1, and 1 plus 1 over 1 plus 1. And here, of course, it becomes a 5x, right? So if you will follow that basic integration formula, you will get and arrive at the correct answer, which is y is equal to 7x cubed over 3 minus x squared over 2 plus 5x plus c. So I hope you understand this one. Notice that we are only answering the general solution. So we're only using or applying step number 1 and step number 2. We are not yet on the particular solution. Let's have the third example. Let's have dy over dx is equal to 9xy. So this is quite different because when we apply cross multiplication, that becomes a dy is equal to 9y dx. So there is still a factor that should not be on its right place. So we should put y onto the other side, right? So what do we do? Very good. So we divide both sides by y. And by dividing both sides by y, we'll now have a variable separable. So it means if it's a variable separable, then we can now put out the integral sign. So we'll have the integral of dy over y is equal to the integral of 9x dx. Then we use the constant multiple theorem. We put 9 before the integral sign. So it becomes the integral of dy over y is equal to 9 integral of x dx. But take note of this one. Isn't it familiar? So this should be familiar with you because this is related to lesson 2.3. Let's recall the integral of du over u. That's actually an ln of the absolute value of u plus c. But in the case of y, there's no need to put c, so we omit that part, and there's no need to put the absolute value. So we assume that the integral of dy over y is already an ln of a positive number. So we only put the c for the independent variable x. Okay, so no need to write your plus c on the y side. So we'll have the ln of y is equal to 9x squared over 2 plus c. But take note that our final answer is not ln of y. It should be y only. So we need to do something with this natural logarithmic form because we can rewrite the natural logarithm as a logarithm to the base e. So observe this one. This is how you rewrite an ln of y. You could rewrite it as a logarithm of y to the base e is equal to 9x squared over 2 plus c. Then, recalling how to transform a logarithm of y to the base b is equal to x, that becomes a y value, which is equal to the base raised to the x value. And this is the entire x value. Take note. This one is the entire x value. So it means that we could rewrite it as y is equal to e raised to 9x squared over 2 plus c. Take note that this is an exponent, okay? That should be a small number written on the upper right-hand corner of e. Okay? So maybe when you write it correctly, you'll make it like that. 9x squared over 2 plus c. So that we could distinguish that that is indeed an exponent, okay? So I think this is a better writing than this one. The PowerPoint presentation cannot make it appear that it's an exponent, but I think this is a better way of writing it. So I hope you find it good. Let's move now to more examples. Let's have y cubed y prime is equal to sine 3x, I mean. So remember to take note that y prime is equal to dy over dx. So let's try to figure out how to solve this problem. So they agree that we could rewrite it as y cubed is equal to dy over dx is equal to sine 3x. So y cubed is equal to dy by cross multiplication. We'll have sine 3x dx. So that was cross multiplied. Then we'll have a variable separable already. So we can declare this one as a vs already. Do you agree? So whenever we declare a variable separable, then we can now put the integral symbols on both sides. So we integrate with respect to y on the left side, and we integrate with respect to x on the right side. Can you follow? Next, we answer now the integral of y cubed dy using the basic integration formula. Of course, this will become plus 1. Then we'll have a 3 plus 1 in the denominator. So I think that becomes y to the 4th over 4, the integral of sine 3x. But take note that when we studied the trigonometric functions, the integral of sine x dx is actually negative cosine x plus c. But we haven't encountered certain examples in which the given is a 3x, right? So what we're going to do here is to use the u substitution for us to answer this expression. So let's review u substitution. So if you are given the integral of sine 3x dx, then we can let this one as your u value. So that becomes u is 3x. Then we get the derivative of 3x, and the derivative is du is equal to 3dx. Take note that we need to make this one as a du. But the du is dx, and it's not 3dx. We don't need 3. So I think we need to multiply an integrating factor that will balance everything. So let's try to multiply 1/3. So that will be cancelled. And what will remain is a 1/3 du is equal to dx. And this is what we need, right? So we can now substitute it by having an integrating factor, which is 1/3. And then we'll have a sine u du. So rewriting it, we'll have 1/3 the integral of sine u du. Next, we can now answer this one. What is the integral of a sine u du? So the answer is 1/3 times negative cosine u plus c. And then we will multiply the negative sign with respect to 1/3. So that becomes negative 1/3 cosine u plus c. But take note that our u is 3x. So we can replace right away the u going back to its x value. So these answer now the problem. So this is equivalent to negative 1/3 cosine 3x plus c. For the next part, we need now to isolate y, but the first one that we need to eliminate is the value of 4. So we have to multiply by 4, if you agree. Then we cancel. So that becomes y to the 4th. Then we multiply 4 times 1/3 is negative 4/3. Then 4 times c is 4c. So normally, mathematicians actually omit the 4 and it still becomes c. Because whatever the value of that constant, it will remain as a constant. But for uniformity, let's remain with 4c. But you could still omit 4. So next is we eliminate the exponent 4 by having the fourth root both sides. Okay, so we get the fourth root of both sides so that these will be cancelled. Okay, when we cancel, then that becomes a y value. Then everything will be under a fourth root. So again, there are times that you can omit 4 and your final answer could become c. So both are accepted. Okay, so you could have an answer which is y is equal to the fourth root of negative 4/3 cosine 3x plus c. So you can have this one as an alternative solution if you do not want to write 4c. I hope you understand. Now, what if we use a different variable, such as dr over ds? So notice that we'll just follow dy over dx, meaning this is your dependent variable and this is the independent variable. So in this case, our r is our y and our s is our x value. So take note of this one. Your r is y and your s is x, so that you'll not get confused. So the dependent variable must be on the right side, just like y, and the independent variable should always be on the right side. Okay, so left side is the dependent variable, and on the right side is the independent variable. So to do that, we'll apply cross multiplication. So we'll have a 3dr is equal to negative 4s ds. Next, we divide both sides so that 3 will be cancelled. So we'll be needing an rdr now. Then, I think this is variable separable already. So this is a vs. So declaring a variable separable means that you can now integrate both sides. So we have the integral of rdr, and then we, using constant multiple theorem, the constant is negative 4/3, the integral of s ds. Then of course, we know the rule. We have plus 1 over 1 plus 1. And then it's same with s. We have a plus 1 over plus 1 plus 1. So obviously, the answer becomes an r squared over 2 times negative 4 thirds times s squared over 2 plus c. Of course, we simplify this one. 3 times 2. So that is a negative 4 over 6. And we can still simplify this one, 4 over 6, so that becomes negative 2 thirds. So our next step now after simplification is to remove all the values near r. So the nearest is 2. So we can multiply by 2. We can cancel now, then distribute 2 so that it becomes r squared is equal to negative 4s squared over 3 plus 2c. The next step is to extract the root of both sides so that the final answer becomes the dependent variable r. So r now is the square root of negative 4s squared over 3 plus 2c. Okay, let's move now to the next one. Find the particular solution of the following differential equations. This time, we are asked for the particular solution, so we will be moving into steps 3 and 4, in which we will substitute the condition. Take note that these problems are quite different because observe that the condition are already mentioned in the problem. Okay, so these are what you call the boundaries for the initial conditions. So there's already a value for y and x so that you could find the value of c. So first thing to do is to apply FOIL method. So we'll have 3x to the fourth, and this one, negative 6x cubed. This one, negative 5x, and then negative 5 times negative 2 is positive 10. Of course, we can rewrite it as that expression. Next, apply cross multiplication so that your dx will be on its position. And we declare this now as a variable separable. So declaring a variable separable, which means we could integrate now both sides. Then we do this one, the constant multiple theorem. So we always answer this one so that the answer becomes y. Then we answer using a basic integration formula. So this is a plus 1, 4 plus 1. It's a plus 1, 3 plus 1. 1 plus 1 over 1 plus 1. And then this becomes a regular 10x. I know I am expecting that you have mastered this one already. So the answer becomes 3x to the 5th over 5 minus 6x to the 4th over 4 minus 5x squared over 2 plus 10x. So that the answer could be this one. So this is what you call the general solution. So we're done with step number 2. We'll now use this general solution to use the given conditions if y is 3 and x is 2. So using the general solution a while ago, we can replace now the value of y, which is 3, and all the values of x will be replaced by 2. So this will just be a calculator technique. You have to manipulate first this one using a calculator. And your calculator should reflect 26 over 5 on the right side. And what we'll do is to transpose 26 over 5 to the other side so that it becomes c is equal to 3 minus 26 over 5. Again, this is a calculator technique. You have to encode that one in your scientific calculator so that you'll get negative 11 over 5. Question. So this is step number 3 in which we have looked for the value of c already. And for step number 4, we solve for y by substituting the value of c. So the final answer is 3x to the y is equal to 3x to the 5th over 5 minus 3x to the 4th over 2 minus 5x squared over 2 plus 10x minus 11 over 5. Any question? Let's proceed now to item number 7. So if you were given this problem, all you need to do is to cross multiply, right? Then next, the given is already a variable separable, right? So we can now put the integration symbols on both sides. Then we can apply constant multiple theorem. Next, we answer. Can you follow? But take note that the arrangement is not accepted in algebra. So you could actually rearrange the answers. Like you start with here. So that the first term will be x to the 6. Then this one. So that becomes negative 2x to the 4th. So that it becomes like that. So the answer is y is equal to x to the 6 minus 2x to the 4th minus 5x squared over 2 plus 2x plus c. And this becomes your general solution already. Again, you are midway your solution. So it means you have to still continue step number 3. So for step 3, we will now use the initial conditions. Y is negative 7 and x is negative 1. Substituting the values, we'll have negative 7 is equal to negative 1 raised to 6 minus 2 raised to negative 1 raised to 4 minus 5, negative 1 squared over 2 plus 2, negative 1 plus c. Obviously, you answer or manipulate first this side. So using your scientific calculators, what is the answer? Correct. So that is negative 11 over 2. We transpose negative 11 over 2 to the other side so that it becomes c is negative 7 plus 11 over 2. And then we'll get c is equal to negative 3 halves. After getting c, then you proceed to the last step in which you arrive at the particular solution. So the particular solution now is y is equal to x to the 6 minus 2x to the 4th minus 5x squared over 2 plus 2x minus 3 halves. So do not forget to write it on the last part of the equation. So this is now your particular solution. I hope you're getting it. Let's move now to item number 8. So we have 2y minus 4x squared dx. Obviously, this is the only expression that is not part of that side. So we put it on that side so that it becomes positive. So we declare now a variable separable. After declaring a variable separable, we could divide it by 2 first, so that becomes dy. So let's simplify further. Then we put them together. Then again, we can make it a variable separable already. And then we answer, we'll have y is equal to 2 integral of x squared dx plus 11 over 2 integral of x dx minus 7 over 2 integral of dx. Next is we answer the integration. So we'll have y is equal to 2x cubed over 3 plus 11 over 2, that's the coefficient. Then we have an x dx, so that will have an x squared over 2. Then, of course, we just put x here. So it's minus 7 over 2x. Simplifying, we multiply 2 and 2 so that it becomes 11 over 4. I hope you understand. So this is now our general solution. Next, we apply now substitution. Okay, using the initial values y is 2 and x is 2. Again, this is just calculator technique. So that becomes 28 over 3 plus c is equal to 2. Then we transpose 28 over 3 onto the other side. So that it becomes negative 22 over 3. Then we'll get the particular solution. Y is equal to 2x cubed over 3 plus 11x squared over 4 minus 7x over 2 minus 22 over 3. I'll proceed now to the next item. So obviously, just need to transpose so that becomes this one. Okay, we use distributive property. Then we transpose. because these do not belong here. The x value should belong to the right side. So it becomes 5x squared plus 2x. Next, we combine similar terms. Don't forget that. So we'll have 5x squared minus 8x. Then we use cross multiplication. And then this is variable separable already. So we'll put now the integration symbols. Next, the usual way. Next, the answer. And using the basic integration formula. And then we write it as a particular solution by simplifying this one. So it becomes -4. So this is now your general solution. Next, we'll answer now using the initial conditions or boundaries, so that we could have 5x cubed over 3 minus 4x squared plus c. Then we substitute y is 0 and x is 3. Calculator technique, that becomes 9. Next, we transpose 9 to the other side, so that becomes c is equal to 0 minus 9. And your c is -9. Of course, your particular solution now is 5x, y is equal to 5x cubed over 3 minus 4x squared minus 9. Let's have the last one. Let's have dy over dx equal to 3, the quantity 2x to the 5th plus 4x cubed minus 9. We simply use the distributive property. So we'll get this one. Next, cross multiply. And then this is now a variable separable. So after declaring a variable separable, of course, the integral sign will appear. Then the usual way. So we use or apply the constant multiple theorem. Then we answer. And x to the 5th is x to the 6 over 6. And x cubed is x to the 4th over 4. And this becomes 27x or -27x. Like that one. Simplify. 6 over 6 and then 12 over 4. That becomes x to the 6 plus 3x to the 4th minus 27x plus c. This is now your general solution. After getting the general solution, we can now use the initial conditions y is equal to 2 and x is equal to 1, so that we could find the c value. Let's replace. So it becomes -23 plus c. So we transpose -23 to the other side, so that it becomes c is 2 plus 23. And your c obviously is 25. Substituting, we'll get the particular solution. So I hope you find this video lesson helpful. Again, this is Sir Peter, your basic calculus teacher.